All right, how we doing, everybody? Doing good. How's the class going? Not too bad, guys. Okay, today we're gonna go over. Well, I want to go over continuous time, but I think I want to talk about one thing because last class I made it a thing where I was like direct 4 and 1, huh? But then I realized I was watching a few of the lectures that Dr. Morris was doing, and now I'm understanding the positives and well, I'm not saying negatives, but because I've been under Dr. Steerbert's, I've been doing this for I think since 2020. So I've been trained under him. This is the first time I'm doing it for Dr. Morris, and he's got a lot of cool tricks up his sleeve, and I can see why both are really strong at their domains. There are signal processing professors. So Dr. Seaver was like, yeah, we only did direct form 2 and transpose direct form 2. And someone's looking at me, transpose direct form 2. Has Dr. Mars even mentioned that? He did? A little bit? So yeah, it's another way of having the feed forward and feedback path. It's a more less memory. It's pretty efficient. It's really cool. But that's what Dr. Stuber would focus on for state space equations. But he wouldn't let us do a direct form 1 block. And I never understood why until I watched Dr. Morris's lecture. It was insane. So I was like, oh, you can do some really cool things. So you know what? I'm being lazy right now. Let's give you a block diagram. What's this right here? It's our output, right? Everyone's understanding what's going on. Plus a1 yn minus 1, correct? Plus a2 yn minus 2, correct? Easy. Is equal to this x and, well, don't forget the b0, right? b0 for our input attenuation, gain, preamp, plus b1 xn minus 1 plus b2 xn minus 2. Really nice block diagram, or not block diagram, equation, differential equation, or difference equations, right? So you guys are gonna make me proud when he says draw the block diagrams. Okay, we're gonna do a direct form 1. I've noticed he draws it with like the lines and the arrows. That's cool. But funny enough, I'm more of a picture guy. So if I were to draw, let's just use a black marker. Direct form 1, xn, right? And then just draw this black dot right there. I like doing it like this, black dot. I like doing it like this, z minus 1, right? That's our memory. And then I'm gonna draw another black dot there, z minus 1, b2, right there, right? b1, b0. Now you understand why I draw the black dots, right? Because I'm like, okay, that's where I'm gonna trace my line, okay? And then what am I gonna do here? Plus, there's no plus here, you just go up there. Easy peasy. First half of the direct form 1 block diagram, feed forward, right? And then we draw like this, okay? Direct form 1 for the feedback paths, z minus 1. And then I'm gonna draw a dot here, z minus 1. What am I gonna write here? Minus a2, right? Where's the minus coming from? If I move this to the other side, what does the output see? Okay, don't fail me, all right? I'm counting on y'all. Let me see, is delay, plus, boom, and then minus a1. Boom. Any questions about this? So I'm doing a second order equation, so we're gonna have 2 delays, okay? But the way that the direct form 1 block diagram, and I'm understanding what's going on, I'm waking up, is that we have 4 memory states, correct? We have 4 memory states. We're gonna have 4 states, right? Which means we're gonna have 4 next states, or you know what I mean, correct? And this is how I'm starting to wake up. The way Dr. Morris was showing, I saw the example problem that he did for direct form 1. It was really cool. And I was like, okay. And he said this question. If you do it differently, that's okay. And that is true. There should be multiple ways of solving a problem. V equals IR, right? You go plus up the hill, down the hill, up the waterfall, down the waterfall, however you want to make the analogies for circuit analysis, correct? Same thing with signal flow charts. You can do Q1, Q2 going up, down, or down, up. I do it going from up, down. So Q1 will be on the top, Qn will be at the bottom, because that's what makes sense for me. If I wanted a first order equation, I would just chop that in half, Q1, boom, right? Makes sense? That's why I do Q1, Q2, Qn, because it's easy for me to just do this because I'm efficient. Okay, I was gonna say lazy, but I'm efficient. Anyways, we have a state right here, right? Cool. So something's gonna be stored here, right? So I'm gonna call this one QX1, right? Of n. Okay. I'm just gonna put it that there, okay? The first state at this x right here, okay? So then right here I'm gonna do QX2 of n, okay? At that node. Everyone following what I'm trying to do? Okay? And then right here, I'm gonna do QY1 of n, right? That's a state. Easy peasy. QY2 of n, okay? This is what makes sense for me. The x's are on one side, the y's are on one side. 1, 2, boom. Everyone understanding what I'm trying to do? Dr. Morris is doing like W's or Q1, 2, 3, 4 or something like that. But I'm a visual learner. I can't do text. I have to see it, and I have to use lots of colors. So if you saw my bachelor's homework, you'll see a lot of colors. Dr. Baker's like, what the heck? Colorful, right? I like colors. So remember those next state stuff, right? If I put this backwards, right? What's this x1 of n? If I go backwards in time, right, I'm going to get qx1 of n plus 1, right? Right, going backwards up this waterfall, right? See this qx2 of n, right? Going up the hill, right? I'm going to go up. I'm going to be at qx2 of n plus 1, right? Next state, because next state turns into a current state with this delay. Everyone seeing what I'm trying to do? Same thing with here, right? If I go up the waterfall, right? QY1 n plus 1. Everyone seeing? And then this QY2, if I go up the waterfall, QY2 n plus 1. Is everyone waking up to what I'm trying to set up? Okay, this is what made sense to me, and this is why I appreciated like Dr. Morris, like, geez. I heard the rumors that Dr. Morris loves state space equations and Dr. Stubrud loves block diagrams, and then vice versa. They kind of hated, Stubrud was like, state space, ew. And then Morris is like, blocks, ew. But they have their ways. And now I'm seeing, like, it's like full circle. So if you want to understand my domain and where I'm coming from, talk to Dr. Stubrud. He'll give you a lesson. He'll be like, what the heck? And then if you're in Stubrud's, talk to Morris, because I'm that example. I'm understanding what he's trying to show you. All right. So I'm doing it like this. This is what makes sense for my OCPD brain. Okay. So remember from last class, everything is made. What do you call it? You can solve for your next states and your outputs using current inputs, current outputs, or current inputs, current states, right? Page 2. Just to clarify, okay? Next states and outputs can be given equal by, what do you call it? Current state and next states. Or inputs, and inputs. And then same thing here. Cool? Everyone understanding what I'm trying to do? Current states, current inputs. That's all I want to solve for these next states and these outputs. All right? So, from what Dr. Morris was saying, I used the purple marker too much, but it's okay. I have next state 1, 2, 3, 4, right? I have 4 next states. Is everyone seeing what I'm trying to do? QX1, N plus 1, this one, this one, this one. There's 4 states. There's 4 delays, 4 memory blocks, 4 integrators, if we're talking about continuous state, okay? So I'm just gonna write it like this. QX1, N plus 1, QX2, N plus 1, QY1, N plus 1, QY2, N plus 1, okay? Everyone see what I'm trying to do there? Because this right here is all my next states, right? This is a 4 by 1, right? Which means our A is going to be a 4 by 4, correct? So let me just use this blue marker, okay? So if I did this big marker right here, and then what's going to go over here? What do you call it? It's going to be QX1N, QX2N, QY1N, QY2 of N. Right? And that's my current states, right? Everyone seeing what's going on? And then plus this B right here, and then my little input. Cute. Current states, current input. And your job for your exam is going to be on the exam, and for your MATLAB assignment is to solve for A, B, C, and D. And then the rest is history. Okay? So, and then, should I do it for completeness? I will. I'll put these markers on the side. Let me use the blue, darker blue. No, let's use red. I like red. Outputs, right? Here's Y, N, right? Is that cool? So I only have one output, correct? Easy, little guy. But I'm going to have 4 states. So that means my C is going to be 1 by 4. Is that correct with everybody? I'll do it like this, and then you have QX1, QX2, QY1, QY2. There you go. And then my input right here is going to be plus whatever DXN. Everyone seeing what's going on? Wait. Is this one? Yeah, it's going to be a 1 by 1 because this is a 1 by 1, 1 by 1. Okay. Ugh. Panic for a second. Anyways, what is? Let me think. Well, we want to solve for this first next state, right? Cool, right? So, what is it going to equal? Here's QX1 N plus 1 right there, right? What's it equal to? What's it touching? X1, right? Or X of N, our input, right? But nothing else. So what does that mean? So no states, correct? 0, 0, 0, 0. Boom, done. And then for this 1, 1. Cool. We're almost there. What about this next state right here? What is this equal to? QX1, right? And then here's QX1 right there, right? So let me just put one right there. Right? And then is it equal to anything else? No. 0, 0, 0. No inputs, right? 0. Boom, done. See how easy this is? This is why I'm appreciating Dr. Morris. It's like, I'd never thought about this. It's really eye-opening that we can do with direct form 1. I didn't think. This is really cool. It's okay, I'm nerding out. QY1, right? What's this equal to? The output, right? But we can't have the output in here, right? So we need to solve for that output equation, right? Let's solve for that output equation. Here's our output equation. So what's y of n equal to? Well, let me do that funny Morris thing. Let me see, what did he do? Let me use a gray marker, lightish pink one. Let me use this yellow one. Use this green one, okay? It was really cute. I liked it. Where he did this. Follow the waterfall, right? He did this. Right? So what's our first path? Xn times this b0, right? So I'm gonna write this, right here. So y of n is equal to b0 x of n, right? Cool? That's my green marker. Let's pull out my yellow marker, okay? So what do we see? This y of n sees this guy right here. Cool? qx1, b1, right? So plus, can you see that there? b1. Can you see that?
Yeah, we can see it.
Okay, cool. From my angle, I can't see. Like the bright light is blinding, so I can't even see what I'm writing, so it's funny. Q, oh shoes, I can't see. X1 of n, okay? Cool? You like the colors? I love the colors. Now we have this path right here, right? Boom. Cool? Plus B2, QX2. Right? It's a lot of work, huh? I don't think he's going to torch you with this, okay? And I'm going to use this pink marker. Because what do we see here? Whoop. Right? QY1 times this minus. Okay, so I'm going to do minus A1 Q Y1 of n, right? Everyone see what I'm trying to do? Now let me use a fifth marker. Let's use orange. Orange, you glad I didn't say? I don't know. Too late for those loud jokes. Whoop. Boom. QY, okay, minus 8 Y A2. Y, Q, Y of 2n. And that's our output equation. Ain't that a lot of work? Whew. Anyways, there's a reason why I did the full block, because you're going to memorize all of this, okay? You're going to put this on your cheat sheet, and then if he says just do this, like if he gets rid of this, just make this 0, right? Or if he gets rid of this, make this 0. Everyone understanding what I'm trying to do? If A2 is equal to 0, what does that mean? It's an open circuit. If it's a 1, it's a short, right? Wire, just a wire. Makes sense what I'm trying to do? You guys like what I'm trying to do? Anyways, let's solve for outputs before I tackle this guy. Let's see, where's my nice marker? So our output, right, has this B0 term right here, right? With the input, right? So here's our input, right? B0. Cool, easy, and nothing else. All right? Look at this QX1 right here, right? Boom, boom, has B1, right? And then we don't have an A0 there, so B1 right there. I'm gonna put the position 1 right there. Position 2. QX2 sees, let me see. QX2 is right here. B2. And then you guys see the pattern? Minus A1 and minus A2. Do I have to go over that? What I just did right there? 1, 2, 3, 4, boom, done. Any questions? Guess what we just did? We just solved for our C and our D. Nice. Now we just got to attack A and B. That's the hard part. So, QY1, right? N plus 1 was equal to Y of n, and that's it. Right? So now all we got to do is just got to punch all these equations. And do you see the copy paste here? Right? If I just put all these up here and this up here, are you guys seeing that? Who doesn't see that? You guys see it in the back? Makes sense? Literally, the output is equal, like the next state is equal to the output. It's a 1-to-1. So guess what? I'm naming myself the king of copy paste. You'll see it in my 420 class for a reason. B1, B2, minus A1, minus A2, and B0. Boom. We're getting there. Final one. What's this one equal to? QY1, right? So here's QY1 right here. It's in position 3. So let's do 0, 0, 1, 0, 0. Sounding like a CPE major right there. Who's a CPE major here? No one? Pesky CPEs. I'll find out. I love the CPEs. They're great. They're great when you need someone to, like, I don't know, code your op amps. What did we just do? We solved for our A's, B's, C's, and D's. And this is for a direct form 1. Let me see. Am I zoomed out all the way? Hope I am. Yeah, I am zoomed out. Okay, but this is for the case that you follow what I just did. Bum, 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 bum. Okay? So what happens if I did bum, 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 bum? So that means things start getting switched around. So what do you call it? If this would be, okay. See how I went 1, 2, 3, 4. Let me use a different marker. Brown. No, I'll use the orange. You see how I did 1, 2, 3, 4, right? You see these big numbers right there? What if I did, I'm running out of markers. This is great. Let me use this blue one. What if I did 1, 2, 3, and then 4, right? See how I circled 2 and 3? So all I do is, you see this second row right here? I would switch that out. It would be, what's his name? 1, 2, 3, 4. So QY1, this guy would get replaced with this guy. So it's like flipped. So basically, your A's and B's, your A, B, C's, D's, they change, but they only change by the rows. So do you see how direct form 1 is pretty simple to memorize? It's not that hard. So you notice there's a row, and this is where the engineers go pattern recognition. B1, B2, A1, A2, minus, minus, okay? And then, this input. B1, B2. Why is the rect form 1 so nice? The output always stays like this. Okay, so if I switch this one and this one around, what happens to these two right here? They just flip around. Okay? Same thing with this guy. What was it? Was it this one? XQY1. If I flip this around, it flips everything around. Boom, boom. You guys seeing what's going on? That's direct form 1. It's just direct. It makes sense. And now I'm gonna say the word woke because this is insane. This, I like this. And you can throw this in MATLAB and never do those for loops ever again. You guys like those for loops convolution? I like them. And never mind, I don't. Or do I? I don't know. Punch this into MATLAB, okay? Sounds cool? So, why did I set it up like this? Let's see. Suppose... let me show you my efficiency. Maybe I should have pulled out the assignment. Boo ha ha. Don't worry, I'm writing this. Give me a second. Thinking. A0 is equal to 1. A1 is equal to minus A1. Give me a second. Yeah, what's up?
Why would we want to use a DF1 rotation? We have a larger matrix than DF2.
Well, it just makes sense. It's like brute force. Let's just say you're about to cram your junior design project in one night. You do direct form 1 because it's just so direct. Of course, it's messy work, but it works. Your output, you see this? See how direct it is? It's just boom, 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 boom. and then you solve for your A's and B's. But it's a little more harsher. Like think of a breadboard, like oh, it's all that spaghetti, but it just makes sense, right? Think of breadboards, like all that spaghetti stuff. Like look at the CP projects. They're like, what the heck? Whereas when you have an efficient transforms direct form two, so creme de la creme. But it takes a little more theory to understand that, but it looks so clean and it's easier to memorize if you know what you're doing. So I can see why Dr. Seabrook skipped the direct form one, because it's a lot. Giving too much freedom to the student makes it to where it's harder for you to understand. For me, it makes more sense. I think this makes sense to me. I don't know if it did for you. Does this make sense to everybody? I think this made sense to me. I'll ask Dr. Seabrook. Maybe we'll force his students to do a direct form one state space equation for the assignment, because I think it's good. Anyways, I don't want to waste time. Okay, help me out. I need to think. Okay, suppose A0 is equal to 1, A1 is equal to, help me, because I know, I can't think, I'm too lazy right now, or not lazy, I'm just blanked out. Yn is equal to, xn minus r cosine omega naught x n minus 1. And then I'm going to do, we call it minus parentheses. So the plus turns into a minus. Oh God, I'm thinking. So the plus should be plus 2r, but it's going to be minus r cosine omega naught y of n minus 1 minus, don't forget the parentheses right there, minus this r2 term. So minus, I'm thinking, r2, yeah, r2. Y of n minus 2. Okay, is this your homework? Are you guys understanding why I put these parentheses right there? Because this is going to equal to your A1, right? The A1 term in MATLAB. This right here is going to equal your A2 term, correct? And then B0 is just equal to 1, right? And then this right here, I could have done plus parentheses minus r cosine omega, and this would have been your B1. Okay, is everyone understanding what I'm trying to show you guys so you guys can get your homeworks done? So, suppose we already had an answer sheet. What are we gonna do? A 0, 0, 0, 0, right? Easy. Okay? Everyone seeing what I'm trying to do? You're going to do this for your assignment? Note, this only works if you did exactly what I did, okay? If you did the way I did it here, state 1, 2, 3, 4, right? You can copy this, okay? If you did it the other way where it says 1, 2, 3, 4, you'll have to shift it a little bit. But point is, pick your way, stick with it, and live with it, okay? So just like controls engineers who stick with doing n plus 1, n plus 2 instead of, the correct way, which is n minus 1, n minus 2. Yeah, controls people do k plus 1, k plus 2, k plus m. Those controls engineers. Anyways, let's not waste time. We have a 1 right here. You see this 1? Just put the 1, okay? Don't be afraid. Okay? Everyone understanding? B1, B2, A1, A2, right? Cool? So that's what I was trying to do right here. I'll write it down. What's A1 equal to? It's equal to this right here, right? Minus 2r cosine omega naught, correct? Everyone see what I'm trying to do? And then B2 is equal to R2, right? Everyone seeing what I'm trying to do? because I could just plug and chug. Cool. Anyways, thinking. B1 is going to equal to this guy right here, minus R cosine omega naught, right? And then the next term, B2, is going to equal to B2. Do I have a B2? Yeah. Wait. This is A2. Sorry. A2. Do I have a B2? I don't have a B2. So you know what I'm going to do? 0. Okay. Minus A1. So I'm going to put a minus. Okay. Minus. What's A1 equal to? Minus 2R cosine. So what am I going to do? Plus 2R cosine omega naught. Okay. Cool. And then what is minus A2? So it's going to be minus A2 is going to be R2. Cool. And then, yeah, I made my matrix a little funny, but who cares? I do. I really do. This looks so messy. What about the bottom row? 0, 0, 1, 0. So I should have drawn them a little more further. So 0, 0, 0, 0. Is that cleaner? That's your answer to your MATLAB assignment. Is everyone appreciating me? You're welcome. What about your B? Here's your answer. 1, 0, B, 0, 1, or 0. What's B, 0? Just 1. So what are you going to do? 1, 0, 1, 0. Hex for A. Hex number A. And that's your B. Boom, boom, done. First half of the assignment. What about your C? Well, I already gave you an answer sheet. It's right there. So what are you going to do? What's B1 equal to? B1 is equal to minus R cosine, omega naught. And then B2 is equal to 0, correct? Right? And then, what's his name? Let's see. A minus A1, so minus plus 2R cosine omega naught. Okay? And then our R2, so it's going to be minus R squared. Cool? Is that cool with everybody? Right? And then what's our D equal to? Just equal to B0. 1. Everyone see the answer? Are you ready to run this in MATLAB? A is equal to, you're going to do this for me, okay? 0, 0, 0, 0. Okay? Wait, hold up. Try this trick for me. ... Does that work? Hope this works. If it doesn't work, I'll be angry. 1, 0, 0, 0. That should work. Why is it not working? Use of 2 dots is an invalid. What? What? No, this should work. Details. No, this should work. Don't you tell me what to do, MATLAB. Yeah, that's what that does. Give me a second. Oh, no, I'm dumb. There you go. So third row is going to be minus R dot times cosine omega 0. You see why I'm doing things the way I do? I'm a visual learner. Okay. Let me see. There we go. What am I going to put right here? 0. Right? And then I'm going to do 2 times dot times R dot times cosine omega naught, right? And I'm going to do the following. Okay, you guys like my picture? Then what's the final term? Minus r dot her power squared. Okay, and now let's do what do you call it? 0, 0, 1, 0, and that's our matrix. Does that make sense? Add a semicolon after the statement. Nah, who cares? I do. R is equal to, what's it equal to in the assignment? 0.9, whatever. And omega 0 is equal to, was it pi over 4? Run it. What's this look like? Matrix. Cool? Everyone seeing what I'm trying to do? Is this a waste of your guys' time? B, what am I going to do? Who liked my visual? 1, 0, 1, 0. You like it? I think I like it. What's B? Yeah? Cool? This is how I do it. If you don't like this, you don't have to. You can do it like, you can also do this right here. I'm going to trick y'all. 1, 0, 1, 0. They both do the same thing. Okay? Everyone understand what I'm trying to do? Same thing as David's visual way. Okay? C is going to equal that B1. Oh, you know what? I'm lazy. I'm so lazy, everybody. Oh, David, what will we do without you? What am I going to do, y'all? Yeah, David, why didn't you do that? Wasting time. Minus R. No, let's not waste time. There we go. B2 is equal to 0. And then A1 is, A0 is already equal to 1, okay? A1 is already equal to, oh, shoot, minus 2 dot times lazy, boom. Are you guys liking what I'm trying to do right now? So we can get you guys home, or at least passing the class. R2. Okay? What am I going to do now that I've set all these variables that I don't have to change multiple times? B1. B2. Minus A1. Minus A2. Oh, David, you did it again. There we go. No, I'm not the king of MATLAB, but sometimes I feel like it. What's this going to be? 1. Boom. You guys like this matrix? What does that look like? Let me show you. Hold up. Where's that piece of paper? Hold up. Hey, where is it? Looks just like that. David's very efficient. Okay? I want things to make sense. I want you guys running your MATLABs and having some fun, okay? You guys can do signal processing, convolution way, or state space equation way. By the end of this course, you guys can run your own MATLABs and do your own research, okay? Sounds cool? What am I going to do with the B? I'm going to replace this guy with B0. Easy. What about this one right here? Wait, hold up. Yeah, same thing. B0. Cool. What about my C? Put this on the side. Put this right here. Here's my C right there, right? B1, B2. Guess how lazy I am. You guys like him, like me being your little your helper? Done. All right, let's get popping. So, how do we do things with this? Okay, we're at that point where we're like, okay, we got our assignment, right? Draw a direct form 1 block diagram. But you got to define your states. Show that to the grader, what you're trying to do. Funny enough, let me tell you a very big warning, okay? Let me see. Before I get to what I want to talk about. Someone might ask, this doesn't exist, right? B2 doesn't exist as a 0. So why can't I just do 3 states instead of the 4? So my A is going to be a 3 by 3. You can, okay? I'm just doing a general equation so that when I want to change the assignment, I have a backup, okay? So what are you going to do with this B2 xn minus 2? This guy right here. Just get rid of that equation, but don't just get rid of it, okay? So let me see. Xn plus 2 plus 2 right here. Here's this equation. This just goes away, right? But there's other things I got to manipulate here, okay? Because I kind of like to, you see this B2 right there? That doesn't exist. That's 0. So I think everything, this row disappears and this just shifts over here, okay? Prove that for me, okay? Do 2 ways. I'm just doing it the general way, okay? So, let's do your assignment, because I think that's what everyone wants. Generate the space equation. So that's what you're going to do, okay? We just did that. Using the transfer function to state space equations. Okay. Let's see. Help. Help TF2SS. Okay, let's see. Suppose you have this equation. But this is going to give you, what do you call it? A's, B's, C's, and D's. Let me see. The B's, the A's. Let me just show you, everybody, because I think someone's going to get confused. 1, 2, this is page 3. Page 4. Okay, what was that equation that we just had? Let me just pull this guy out. Boom, 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 boom. There we go. What's the numerator right here? So if I were to do, x, z or something like that, right? Z transform of the top part, or was it? Wait, what was it? No. H of z is equal to y of z over x of z, correct? Everyone see what I'm trying to do? The numerator over the denominator, right? So, let me think. I gotta write stuff out, okay? Everyone can agree that if I did a z transform of all this in the top right here, right? I'm gonna get the following. Yz is equal to, or yz of 1 plus a1 plus a2. Wait, no, hold up. Yeah, plus a2 z minus 1 z minus 2, right? Everyone see what I'm trying to do right there? Right. Is equal to xz. And then what do I have right here? I just have the input 1 plus b1z minus 1, correct? So then if I do this over this, I'm going to get hz is equal to 1 plus b1z minus 1 all over, what do you call it, 1 plus a1z minus 1 plus a2z minus 2, right? But we need to make sure these are equal lengths. So what am I missing right here? I'm missing a z2 term, right? So if I wanted to plus, what do you call it, b2z minus 2, where b2 is equal to 0, right? So if I were to draw the numerators in terms of this, in terms of like ones and zeros, it's going to be 1, b1, and 0. If I just force that to be 0, right? And denominator, what's it going to be? 1, a1, a2, correct? That's what you punch in MATLAB, okay? But if you're lazy like me, that's B2, okay? Everyone see what I'm trying to do? So, let's see, how do I punch this in MATLAB so you guys don't bark at me? So capital, I'm gonna do this, num is equal to 1, b1, 0, okay? Make sense? Or should I do this, b2, just for clarity, right? What about then? It's gonna be 1, a1, a2, cool. So now I gotta do my state space is equal to TF to SS of my numerator and denominator, okay? Ooh, there we go. Guess what just popped out? State space equation. I don't know if I like that. Oh, whoopsies. Oh, no, I don't want to write that. Shoes, let me see. Oh, my laptops are not even charging. It's okay. AM, BM, CM, DM, M for MATLAB, okay? That's your answer, all right? Boom. What's that right there? That's our A. You see something wrong? It's a 2x2 and it's not the 4x4 that we calculated. So you know what you're gonna try and do? Verify with this direct form 2 block diagram. Because let me show you what it's trying to do, why we're not getting the right answer. Let me see. Let me see. Direct. No, what? Canon. It doesn't tell me. Because Dr. Stewart makes this very apparent. Let me see. Anyways, that's what I would. This would generate you those A's and B's. So you know what I'm going to tell you to do? If you do the second order, or not second order, the what do you call it? The direct form 2. We only had 2 memory blocks, correct? So you're going to only get 2 states. So what does that mean? MATLAB uses a direct form 2 to calculate your A's and B's. Okay, so you're going to see this is going to match your hand calcs. Okay, but I'm doing direct form 1 because I think a lot of people are a little lost with this one. Correct? I was too. Okay, so I want to prove that I'm right because I think I want to be right. Okay, we did that. Okay, and you're going to verify this for me in your homeworks. Okay, so I'm going to do your homework, but in a different way. Equal length functions. the numerator and the denominator. The MATLAB result should match your hand solution. Yeah, because funny enough, even transpose direct form 2 is going to be different. You'll see. But yeah, this answer is going to match this one, okay? I'll tell you that right now. And then equal length functions. Why would you need equal length functions? TF to state space, discrete. Okay. Let's keep going. Let's keep going. Using the state space function, calculate the frequency response. So what am I going to do, y'all? Help. Oh, right, no, wait. Help SS MATLAB. Boom, okay? And then you're going to make sure TS is equal to -1. So what am I going to do? My system is going to equal to state space of A, B, C, D, okay? And note, this right here is for my DF1, right? Direct form, okay? I'm gonna run this. Oh, arguments of double. Now, let me just, my laptop's dying, but I think we can survive for a little bit. Oh, -1. State space? Wait. Huh? Hold up. A, B, C, and D. N by N, N by N, Y, yeah. A, B, C, D. Oh, don't tell me. Uh-oh. Oh, no. Oh, no. I think I have an emergency, y'all. I don't have the controls toolbox. So what are you going to do? MATLAB online. Because I don't, you see, I cheaped out. No, that's my personal. No, David. Okay. No, it's going to make me do the thing again. No. Don't like it. But point is, if you didn't buy the controls toolbox, you're going to see the same error as me. So I like it when I make mistakes in front of you guys, okay? Shows you that I'm not perfect. Okay. Come on. Want to run MATLAB? Let that run for a second. Come on, MathWorks. Is it running? How's your guys' days? You guys feeling good for the exam? Do you think state space equations are going to be on the exam? Yes. State discrete time? Yeah. What about continuous time? Of course. What's so different about a discrete time or continuous time? Integrators. Okay. Come on, Dave. Work. Open MATLAB online. Come on. You got this, little guy. That would have been so nice to show you. The point is, all you're going to do for your assignment, and I have content from the past you can use, is you're just going to follow block by block. Oh, yeah, the squeeze function, okay? The state SS function does something weird, so you have to use the squeeze function because it's going to pop you out like a three-dimensional matrix. So a 1 by 1 by 3. So you don't need the middle part. You just need get rid of the 1 and the 3. So use the squeeze function. And this is like just step by step. And then the input, you already know what to do, okay? This is not a hard assignment. I think you guys can get this done by Friday, right? Okay, so come on. Are you kidding me? Come on. MATLAB. Hello. Open MATLAB online. You click on this. Maybe if I do the following. Chrome. MATLAB online. There we go. Okay, let's speed run. Okay, what am I going to do? King of copy paste. Someone's going to make a sticker of that. Oh, yeah, I'm printing stickers tomorrow. Oh, shoes. Okay. Yeah, I'm bringing them to class. I bought my professional sticker cutter. Okay, you're going to like it. Both of them. Okay. Run it.
Thank you.
It worked, everybody. Woo! It recognized the A's, the B's, the C's, and the D's. What does this look like? That's our system that we created with our direct form 1 block diagram. We're ready to program. All right. So now what am I gonna do? We're running out of time. We're running out of time. We're running out of time. Shoes. Morris, please notice me. Come on, I want to get your homework done. There we go. Whee. 0 pole and DC gain, 0. How do you use the 0 equation? Okay. Oh, this is easy. Oh, gosh. Oh, God, I don't like this. MATLAB, my zeros is going to equal to 0 of my system, okay? What are my zeros? Boom. I have 1, 0, right? You guys know that? I have 1, 0, right? Cool? Or actually, no. I have 3, 0, sorry. Does everyone understand what I'm trying to do? Let me do this next page. Okay, 1 plus b 1 z minus 1, 1 plus a 1 z minus 1 plus a 2 z minus 2, right? But if I multiply the top and the bottom by z squared, I'm going to get z squared plus b1 z minus 1, right? So that means I'm going to have 2 zeros. No, this is going to equal, oh, I got it blanked out. Z minus 1, z2, z1 plus b1. Right? Right? Oh, z. Correct? Why am I getting, so 1, 2, I have 2 zeros. I should be getting 2 zeros. Anyways, I'm wasting time. My poles is going to be pole of my system. There's my poles. Like that. My gain is equal to gain of my system. What's my gain? What's the assignment tell me? DC gain, don't forget it. DC. What's my DC gain? 0.23, right? What's the next part? Oh, shoes. The frequency response. No one told me. Mag phase of freak response of my system. Boom, baby, let's go. And then figure to plot, no, semi-log x mag and phase, but remember that it's going to be 20 times log 10 of magnitude, right? And phase, we got to convert that using degrees, because I love degrees, times 180 divided by pi, right? And then everyone's like, whoa, what's David doing? Hello, MATLAB? Don't choke on me now, please. I need you, MATLAB. Did oh, ooh, ooh, ooh. My system is 1 by 1. What is my mag? Ah ha ha ha. 1 by 1 by 50. And what's my phase? 50 by 1, which makes no sense. So you know what I'm gonna do? Mag is equal to squeeze mag. There you go. Boom. Now that should work. Oh, because I forgot. Oh, whoops. I'm dumb. X. And then this one is going to be omega. Hold up. What's my omega? Hold up. I'm choking, y'all. From 0 to 2 pi. Whoopsie daisy. How do I use freq response? Help frick response. What's it take? Freak resp. It's not telling me what I want to do. Freak response. Response output frequency. Yes. Oh yeah, I'm running over time, so you see, freak response, controls, toolbox, freak resp. There we go. Come on. There we go. System and W. Sorry if I'm wasting everyone's time. Omega is equal to 0. Pi divided by 100. 2 pi times pi. There we go. And omega. There we go. Go. And let me just plot this. Boom, baby. Oh, come on. Come on. Oh, wrong again. Woo! Let's go! And then what am I going to do here? Subplot 2 by 1 by 1, position 1. And this right here is going to be subplot 2 by 1 by 2. Correct? So we can get our phase. Phase times 180 divided by pi. Boom, baby, boom. Is that correct? That's my degrees. And you guys will figure that. Oh, my goodness. Absolute value of mag. Whatever. But you see that? What's going on? What's our maximum? That's our resonance. We got 2 poles. 1 pole right there, 1 pole over there. Cool. And I'm not so sure why this is not happening over here. But something does feel off. I don't know about this. Oh, you know what? Don't use semi-log x. Plot, whatever. I knew something was wrong. There you go. Linear phase. Ow. You guys like that? Where's the pole? 2.02, right? What's pi divided by 4? 0.78. Sorry. 0.78. So the pole should be right here. This is 2 pi, 3 pi, normalized. You guys will verify that for me, okay? Are there any questions about this? Was this valuable? Guys, finish your homework. Actually, let me see. Check. 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 Generate 2 poles. Yep. Do I say to use semi-log? No, just use plot, okay? Impulse, step, you guys will be good. Any questions? Have a good day.